Okay, so this is the revision video for topic 6 for GCSE Astronomy, and we will do 6.1 to 6.17. Okay, so the first part, as you can see, I'll just run through it, says be able to recognize the following astronomical phenomena visible to the naked eye. So there's a bunch of them there. I won't mention the sun and the moon. Hopefully we can recognize those. So here we have constellations and asterisms. So if you imagine that the Earth is surrounded by a sphere, and then all the stars are placed on that sphere. So there's nothing further away, there's nothing closer. So all the stars are equal distance away, which, for before we understood deep space, we had no reason to know that it wasn't like that. So on this sphere, which we call the celestial sphere, we've split it into 88 parts. Those are called the constellations. Now, within those constellations, there are well-known patterns. The patterns are called the asterisms. Now, an asterism often has the same name as the constellation that it is in, and something like the Big Dipper is an asterism, but it's part of a larger asterism, Ursa Major, the Great Bear. So, constellations, parts of the sky, 88 of them in total, asterisms are the patterns. Now, clusters, it mentions, being able to recognize clusters. I think you just need to be able to recognize a black and white image of something like this in the top right as a cluster. Clusters are found in our galaxy, the globular clusters, the older stars that never quite made it into the main part of the galaxy, found in the galactic halo. And then you have the younger stars, which are in the open clusters, which are found in the spiral arms. Galaxies. So there's five classifications of galaxies, well, five types of galaxies, I should say, sorry. But you can split those into two categories. The first category will be places where stars are being born. So that's these are big, randomly shaped dust clouds. And then you've got places where stars have died, so the big star explosions, which are much more circular. So here you have absorption, emission, and reflection nebulae. And here you have the planetary nebulae and the supernova remnants. So the supernova remnant we'll come back to later on. Comets, you've got to be able to recognize comets. If you were to sketch a comet, there's four parts to it. So this is the tail, the ion tail and the dust tail are only visible when it gets closer to the sun. If you want to know where the sun is, the ion tail will point directly towards, so the sun is that way. So the sun will be towards there. It's in direct line with the ion tail. But the dust tail would be showing essentially where the comet is coming from, pretty close to it, been blown off slightly, but so it's pretty much moving down there, and the sun will be over here somewhere. Okay, and comets leave a trail, and every year we'll go through that point where the comet has passed through, and lots of little debris will come through our atmosphere at the same time each year, and that will be a meteor shower. So meteors are just flashes of light that travel through the sky, only visible for seconds, and they appear to come from a point in the sky that's known as the radiant. You need to understand that term. Aurora. Being able to explain what an aurora is one thing. It's charged particles from the sun that get funneled into the Earth's atmosphere because of Earth's magnetic field through the poles. And then being able to explain what they look like is the other type of question. So describe the appearance of aurora. And that's just green light, green and blue light across the sky found near the polar regions. Now, mentioned the supernova remnant before. So a supernova, I think in the last 1,000 years, there's only been 3 visible from Earth. So the huge explosion of a giant star, well, I should repeat that and make it a bit clear. Only 3 visible to the naked eye. But there's many visible every night with a telescope, and what you would see is something like this, where you have a um, a point here which suddenly becomes very bright. So for about a month, you'd see that point there within a galaxy, but that of course is with magnification of a telescope. So supernova, just a bright spot appearing in a galaxy. Okay, artificial satellites you would see as a white line moving across the sky, a light moving across the sky, whereas aircraft you'd see blinking. So that's how you tell the difference. They'll flash on and off. There are certain things now that you need to be able to recognize. That's the Big Dipper or the plough. which is part of Ursa Major. There it is. And famously, it's got a double star in. That's an optical double, which means they're not actually next to each other. They just look next to each other because of the angle that we're looking at. Orion, being able to recognize Orion. There's Orion's belt, shoulders, and his knees. And this is the bow. There it is. There's Orion. Cygnus the Swan. Again, being able to recognize it. It is very bright star Deneb. Cassiopeia, which is a W or an M, being able to recognize it. Sometimes you're asked to sketch it. Then we have the Southern Cross. And then you've got the Summer Triangle, which is 3 very bright stars from 3 different constellations or asterisms. So you've got Deneb from Cygnus, you've got Vega from Lyra, and you've got Altair from Aquila. You can see what they would look like there, very bright. And then you've got Pegasus, within which is it's the square, the great square of Pegasus, which is quite visible, and you can sometimes count the stars visible with the naked eye in the square of Pegasus, and that'll give you an idea of how good the seeing conditions are that night. So pointer stars now. So you can use Pegasus to find 2 things. You can, this is viewing it from the same angle as the image I've just shown. So from the far right, if you go down, that's the Fomalhaut. And Pegasus is the winged horse. And Haut sounds a bit like horse. So you can think formal horse, Fomalhaut. So down from the right. And then if you follow it up here, there's a branch off here. And that will lead you to the Andromeda Galaxy. And that's the only thing visible to the naked eye that isn't in our own galaxy. It's the Andromeda Galaxy. So we can use the plough to find a couple of things as well. So on the right here, if you follow this right-hand side up, that will lead you not perfectly, but very close to Polaris. And then you'll spot Polaris because it's very bright. And then if you follow the arc of the handle, that will lead you down to another very bright star, Arcturus. And then finally, Orion. So we use Orion to find 3 different things. We use its belt, go across the bow to find Aldebaran. So across the bow to find Aldebaran, although it's not exactly spelled like that. If you carry on, you'll see a cluster of stars known as the Pleiades. Now, if we go down from the belt, that will lead you to the dog star Sirius. So you can think of it as the dog sitting at the hunter's feet, which is Sirius is the brightest star in the night sky. Okay, understand why is the range of constellation, asterisms, star names among different cultures. I've kind of hinted at this, but this sentence, you can pause it and read it, but that pretty much just sums it up, really. So a range of cultures over many years. Be able to use information from star charts. You may not have used a planisphere, but you should get one. It wouldn't cost you much and very useful. If you turn the time dial to match the date dial, so if you wanted to go out at 11 p.m. on the whatever of April, and then you just turn 11 p.m. to that, and then this window would turn, and then you'd be able to see all the stars that are visible at that time in your sky. Now you do need to buy a planisphere that is set to it is made for the right area that you're viewing from. So you can see this is latitude 30 degrees north. Okay, there's other options. Stellarium, hopefully it's something you've used, and you've got Google Sky Map, which you should download onto your phones, and it can help you find your way around the sky. So you ideally, if you wanted to observe a certain star or galaxy or planet, then you would plan your observing before you went out, trying to find the time when it was at its highest point and the sun wasn't up and there was no full moon, or ideally the moon wouldn't be up as well. You want this the sky to be as dark as possible. You want it to be as far away from the ground as possible to avoid the light pollution, and obviously it's got to be at night time. So light pollution, there's the definition of it, mostly caused by pollutants in the atmosphere, make it glow a bit, but then just unwanted light, street lamps, etc. Now, I've talked about the celestial sphere already, but the celestial sphere has poles just above our north and south pole, and it has a celestial equator which surrounds our own equator. So directly up from our own equator, that's the celestial equator. Now, these are things that people can get a little muddled up with. We have 3 ways of finding our way around. The first thing is latitude and longitude. So that's our way of finding our way around the Earth. So that doesn't mention it here. If you project the celestial sphere now, we have ways of finding our way around the celestial sphere. First one, which goes from the celestial equator up to the celestial poles, down, is declination. So the north celestial pole is 90 degrees north declination, or plus 90 degrees, whereas that goes down to minus 90 degrees. Then you have right ascension. Now, right ascension goes around the Earth, the celestial spheres. You can see it, and it goes around in 24 hours. So it's nothing to do with time. It always uses the same system. So, well, we can use it to see how long ago, though, that something did pass the meridian, which I'll talk about shortly. So we've got 24 hours. So if something is 2 hours past, you can see how far around the celestial equator it is. Where did we start it from? Latitude and longitude were obvious. We started them from equator and, as you know, Greenwich. But the vernal equinox, so it's where the sun crosses on the 21st of March, and the sun is directly above the equator on 21st of March. So that point in the sky is the point where we mark 0 hours from for right ascension. So everybody, if you pick a star, you can give its right ascension and declination at any point in time. Altitude and azimuth are just for you. So you are the person relevant for altitude and azimuth. So somebody in a different part of the sky, in a different part of the planet, sorry, will have a different altitude for a certain star. So that is what the angle is above the horizon. That's the altitude of the star. And azimuth, even though this diagram shows it from north, it can be measured from north, but it's typically the angle from south. So if you're viewing south, how far round is it? Now it's still measured with the hours and minutes there. Okay, but very useful because you would have like your local sidereal noon, which would give you the idea of when it crosses your meridian. Okay, so the altitude of Polaris above the ground that you look at. So if you went out tonight, found Polaris, measured the angle that it is from the ground and found that to be 55 degrees, that means your latitude is 55 degrees. If you're on the equator, then the latitude looking up to Polaris will be 90 degrees. Sorry, it will be 0 degrees. Take that back. So it'd be looking right along the horizon. And then if you were at the North Pole, then you would look directly up to Polaris. So you're at 90 degrees and Polaris will be at 90 degrees as well. So your latitude is the altitude of Polaris. Now, you get charts that look a bit like this in the exam. And this is your hour angle. So actually the hour angle is the time between crossing the meridian and your observing time. So here you can see that the hour angle measured, it's equivalent to azimuth here, really. So it's crossed your meridian 3 hours ago, which the meridian is the line that kind of runs through south. So it probably would have been at its highest point 3 hours ago. So it's plus 3 hours, it's moved on. And then you can see the declination here. So this is only 12 degrees from the North Pole. So that's its polar distance, which is something that's measured as well. So this is how far away from the North Pole. It would be 35 degrees away from 90 degrees declination. So that would have a polar polar distance of 35 degrees. Okay, so this hour and minute, it is useful. It can see how long ago it crossed the meridian, which is useful. Be able to use information on equatorial and horizon coordinates to determine the best time to observe a particular celestial object and the best objects to observe at a particular time. So, if you look north, the stars will appear to rotate around Polaris. Polaris will pretty much stay where it is, and the stars, went the wrong way there, will go anti-clockwise around as you're observing. So, they will cross this point, which is the line to north, here and here. So that's when they culminate, but this point here is when it would be the best to observe. And then here, anytime you look south, everything appears to just go from east to west, including the sun and the moon. So when they cross the meridian, they will be culminating, and that's the best time to observe them. Understand in relation to astronomical observations the terms cardinal points. Cardinal points is your north, south, east, and west. Culmination is when it crosses the meridian line there, so it should be at its highest point. The meridian line is this line, this imaginary line that just runs through south, sometimes really referred to running through north as well, but this is just, for this course, just think of it running through south. Zenith, your zenith, if you go and stand outside and you look directly up 90 degrees to the ground, anything there is at your zenith. Now, because we live outside of the tropical regions, we will never ever have the sun at our zenith. And circumpolarity is when a star does not dip below the horizon. So if I watch this star run around here, you can see it never, in a 24-hour period or 23-hour 56-minute period, it will never dip below the horizon. So that star is circumpolar. This star here will dip below the horizon. So that is not circumpolar, non-circumpolar. So how would you work that out? You can see the stars here. These are all circumpolar stars. But then if a star was out here, it would dip below the horizon. So you have to work it out whether it's circumpolar or not. The Polaris is at 90 degrees declination. So here is 55 degrees latitude, which means Polaris is 55 degrees above the horizon. So 5, 15, 25, 35, 45, 55. So your horizon would be at 35 degrees. So anything that has a declination of 35 degrees, then it would just be on that line. So anything a declination greater than that would be circumpolar. Anything less would be non-circumpolar. So what you would do is you would take 90, the number 90, subtract your latitude. So 90 minus your latitude. So in this case, that would give you 35. And then anything above that number is circumpolar. Anything below that number is non-circumpolar. Okay, so there we go. 90 minus the latitude equals the declination above which a star will be circumpolar. When it crosses the horizon here, when it crosses this kind of meridian line, we have this idea of upper transit and lower transit. So this is the lower transit, and here is the upper transit. Okay. And diurnal motion is just the idea of day and night. So obviously the rotation of the Earth. And then be able to use information about rising and setting times of stars to predict their approximate position in the sky. Well, looking south, which is this would likely be about, it's kind of equal time between here and here as it is between here and here. So if there is 10 hours between rising and setting, then 5 hours after rising, you would expect it to be culminating, crossing the meridian at its highest point and being the best part for observations. Okay, so the textbook covers this as well, I think page 6. So use both together and then have a go at exam questions based on this. I hope that was useful. Thank you very much.